And welcome to the Evidence and Reasons for the Christian Faith video channel. I hope the audio is coming through. I've been having some problems getting my computers working lately. A few of them have been breaking down, and I'm having to do these, what I call these Frankenstein kind of broadcasts, where I have one computer handling the audio and the other doing the video. I'm trying to get another computer online. So greetings to all of you. I've seen in the comment section celebration for a victory for the unborn. And I really never saw this day coming. May the Lord heal our land and let this awful sin stop that is causing our nation to invite more and more of the judgment of God. And maybe there's a little bit more of a glimmer of hope for maybe the delay of Judgment Day happening. So let me just offer a quick prayer. Lord Jesus, so many things to praise you for, and also there are things that are heavy on our hearts tonight. Help us to focus on you. Let this stream, even though it talks about prebiotic chemistry, help it to be honoring to you, in Jesus' name. I actually had other things I wanted to share tonight, and I might actually even do a separate reading and a stream on psychopaths and preachers. It might be surprising that the most popular profession of psychopaths, at least or sociopaths, according to, they did a clinical analysis of people that scored high on the sociopathy or psychopathy scale, and they took different professions. They found that the most popular profession for sociopaths and psychopaths is preachers. Now, what does this have to do with evidence and reasons for the Christian faith? I've long suspected that in the modern implementation of Christendom, not necessarily generations past, it's organized around personality cults many times, and it's not necessarily all about being Christ-centered. And I know that may sound disturbing, but I've been seeing firsthand in the congregations I've been a part of. There's a lot of application of what looks like mental manipulation, brainwashing, etc., socialization of people to act a certain way and behave a certain way, and that has disturbed me. It also explains that if that's been the policy of how a lot of Christianity had been sustained, or at least preserved, in the last few decades, that explains also why the lack of focus on examining evidences for the Christian faith, evidences for the hidden God, who has revealed himself in the things that are made and also in the archaeological record. So, yes, I might actually just do a second stream after this and do a reading on that, just so I can compartmentalize things. And I might do that. My heart's been a little heavy today. Some things with the lawsuit at McLean Bible didn't go our way today, but this isn't the end of it. This is definitely not the end of what's going to happen. But it's a setback that's been breaking some of our hearts. So we'll see where this goes. But also, this is a day of hope. That sometimes when many bad things happen, God just does something that you just wouldn't expect. And I hope, many of you know that I'm not a pre-trib millennialist. I would be classified as a classical millennialist, and that would be post-trib. And that would mean I believe that when the Antichrist comes, if he's coming soon, many Christians might see him, and that'll be not a fun time to be alive. And so maybe for only just a desire to avoid pain, I'd like to see society hold together for a little longer. And so anyway, sorry I have to pour out kind of what's heavy on my heart. I should really get to business here. I want to credit Dr. Fazell Rana, who is an old Earth creationist. I asked him specifically, I said, is it fair for me to characterize you as an old Earth creationist? He said, oh, yes. But specifically, he is what we would call a day age creationist. I think that's the more accurate term to describe his particular position. And that also, there's one nuance here that's very similar to young Earth creationism. In his book, The Origins of Life, he co-authored with Hugh Ross, he posits that many of the major life forms were either rapidly or instantaneously created. And I like that, instantaneous. And I asked him point blank, do you believe in universal common ancestry? He said no. So he accepts the idea of the possibility of creatures just coming to being just like that. And that makes a lot of sense also mechanically. And in that, and this was a recent interview, you should be able to find it on this channel. He mentioned this particular paper. It's in Nature Communications, and let me just show the title first. And by the way, greetings, Patrick Alexander. I tried to write you earlier. Greetings, David Neff. Let me just, I want to make sure I acknowledge you, gentlemen. I don't, News Unit Underground asked, do I got a link to join? I actually don't have open mics on my channel. That's why there's low drama here. So I don't have open mics. So, but thank you for asking. And so let me just say hi to everyone. Patrick Alexander. Let's see if David Neff is here. News Unit Underground. In his image. So greetings, everybody, and I was just typing a greeting. And I didn't need to show that. You got to see me typing. So the author of the paper is someone known as Where is it? I can't believe I can't see. It's Clemens Richert. Clemens Richert. And let me just show you his publication list. I'm really messing this up. Go back here. All right, let's look at his latest ones. Just to highlight, just to understand the convention, when they have multiple authors, often, not always, the last author is the supervisor of the laboratory where the publication was written. Sometimes it's the reverse, but often that's the custom. So you could see then that the co-authors are probably students of Clemens Richert. And so let's see, he has like 182 publications going all the way back to 1995. So this is already a almost 30-year career. And I'll just read some of the titles. Enzyme-free copying of 12 bases of RNA with dinucleotides. Efficient oligomerization of aromatic amino acids induced by gaps in 4 helix. Extension of ethylpyridone, thymidine analog. You can see all the chemical diagrams there. Single nucleotide translation without ribosomes. Single nucleotide translation without ribosomes. By the way, that would be a article related to prebiotic chemistry. And I could just go on. I mean, I want you to appreciate, I'm showing this because my jaw dropped at how many publications he has made, the contributions to chemistry. It's dealing with RNAs and DNAs. And I would thus classify this as being him being quite qualified to comment on prebiotic chemistry. By the way, I am doing a tag team debate with someone who recently recommitted his life to Christianity, albeit the Catholic persuasion. Now, I certainly disagree with Catholic doctrine. I became a Christian when I was a Catholic and then went on to be a Protestant. So I don't automatically assume someone who's Catholic is not a Christian. I just think he's mistaken. And because I believe I got saved while I was a Catholic, and it took a couple years before I left the Catholic profession. Okay, so we're already up to 60 publications, and this is just sorry about this. This is kind of aggravating. I'm having some problem with my cursors, but I'm just going to keep scrolling through this. I want you to appreciate the career this represents. And you could see all of the DNA, RNA type things here. And you're like, what does this have to do with God? Well, if you'll forbear with me, I just want you to see he is extremely qualified to be commenting on this. Goodness. All right. Well, enough of that. I think he was up to 189 publications. We got through like 184. I don't know why my computer's going so squirrely on me. All right, 187. Okay. So enough of that. Prebiotic chemistry and human intervention. Experimentalists in the field of prebiotic chemistry strive to reenact what may have happened when life arose from inanimate material. How often human intervention was needed to obtain a specific result in their studies is worth reporting. Let me make this a little bigger. When Diego Maradona was asked about having used his hand to score a goal in the quarterfinals of the 1986 Soccer World Cup, he initially claimed that there had been divine intervention and the term hand of God was coined. Okay, maybe I need to look this up because you're not supposed to use your hands in soccer unless you're the goalie. So Diego Maradona. Let me just look this up because this could be Diego Maradona, hand of God. Okay, I think Emery, loving sports, he might actually know about this incident. So let's see. The hand of God. La mano de Dios. La mano de Dios. The hand of God. The hand of God was a handling goal scored by Argentine footballer or soccer player Diego Maradona during the Argentine versus England quarterfinals match of the 1986 FIFA World Cup. The goal was illegal under association football rules due to Maradona using his hand, but because the referees did not have a clear view of the play and video assistant referee technology did not exist, it stood to give Argentina a 1-0 lead. Argentina went on to win 2-1, with Maradona scoring a second goal, now known as the goal of the century, en route to claiming the World Cup. Oh, that's aggravating. It keeps coming, that page keeps refreshing itself because I guess of the commercials. The goal's name derives from Maradona's initial response on whether he scored it illegally, stating it was made with the head of Maradona and a little with the hand of God. Maradona later said he considered the goal symbolic revenge for the United Kingdom's victory over Argentina in the Falklands War 4 years earlier. Ouch. Okay, enough of that. So at least we know that the legend there. So the hand of God was coined. Hey guys, if you want to write a peer-reviewed paper about abiogenesis and you want to insert the name God, I think that would be a good strategy. If you wanted to put God in your peer-reviewed papers, make an abiogenesis experiment and you do all the things of human intervention and say that's the hand of God. Or that's simulating what the hand of God would have to do. So this is a clever way. And he basically created this meme. It's the hand of God dilemma. So let's go on. Oh, yes, Jesus Garcia. He said, La mano de Dios. There had been manual intervention and there had been understandable interest of the player not to admit it. So there had been manual intervention and there had been an understandable interest of the player not to admit it. Organic chemists, if not all experimentalists in the field of prebiotic chemistry are faced with a similar dilemma. We do our best to perform experiments that we believe reenact possible steps of prebiotic evolution, but we know that we need to intervene manually to obtain meaningful results. Simply mixing chemicals and watching for a living system to appear from the broth seems unreasonable to me. And remember, I listed that very long list of peer-reviewed papers. He would be qualified to say that. This approach has never worked, and it is not expected to work, at least not if one is limited to the lifetime of a human, let alone the duration of a funding period or a PhD thesis. So what is a reasonable level of intervention by the experimentalist in prebiotic chemistry, and what are plausible prebiotic conditions in this context? And Jesus says, God bless you, Sal. Dios le bendiga. For experimental scientists, there is a need to start from defined conditions, and results can only be trusted if they are reproducible. So there's little doubt that chemists will want to start from known quantities of pure chemicals. Such pure chemicals scenario is unrealistic prebiotically. Organic compounds produced from simpler starting materials on planets are usually found as mixtures of structurally related molecular entities, but necessary. So they're purified, and that's unrealistic, but it's necessary to do the experiment that way, and not have contaminants. Further, the ideal experiment does not involve any human intervention. A reaction or reaction network is allowed to unfold, and the sample is only broken up when the experiment has finished. Perhaps samples are drawn, as in the famous Miller experiment, but there is no addition of new chemicals or an artificial change in conditions. This type of single-run experiment has worked well for simple processes, such as the formation of sugars in a Formose reaction. Now, if I go to review this in the academic channel, we might actually go into these specific reactions, but we're gonna bog this down if I start getting into those details. The oligomerization of activated nucleotides to give short RNA strands, or the Miller volcanic spark experiment that produced simple biomolecules mentioned above. For experiments aimed at demonstrating chemically more complex processes, such as multi-step synthesis, mimicking biochemical pathways, or genetic replication, repeated interventions by the experimentalist have been necessary. Each step needs a specific chemical environment or set of conditions to occur in high yield. For example, an elimination reaction needs other conditions than an addition reaction, and assuming that both will occur simultaneously in the same solution is unrealistic. So this is really bad, where in one scenario you have to purify everything so you get just the thing you want. And so let's say you only have like 0.1% of the thing you really want. You're going to get rid of the 99.9 whatever percent that's bad. Now you have that purified material. And then after it's purified, you're going to add the next chemical. And he's saying that's unrealistic. And I want to say, duh. So let's go on. I mean, unrealistic is an understatement. We have to, to represent scenarios like that as a prebiotic pathway is delusional at best, fraudulent at worst. In any case, in the cell, the individual steps of a biosynthetic pathway are usually catalyzed by different enzymes. Each enzyme creates a specific microenvironment for a reaction in its active site. For potentially prebiotic, enzyme-free multi-step synthesis, a chemical workup at the end of a reaction is often required. involving steps such as precipitation, crystallization, or other forms of handling and purification, and often drastic change in chemical conditions from one synthetic transformation to the next. Understandably, this has drawn the ire of those who feel that no or only minimal intervention is allowed for a process to be called prebiotically plausible. After all, it is not easy to see what replaced the flasks, pipettes, and stir bars of a chemistry lab during prebiotic evolution, let alone the hands of the chemist who performed the manipulations. And yes, most of us are not comfortable with the idea of divine intervention in this context. Okay, so we know where he's coming from. Now, I got to point out something. If you want to claim that you've advanced prebiotic chemistry, what I saw and what James Tour was very good at showing is you claim you got a reaction to happen, and then you don't, you kind of are sketchy on the details and how unrealistic it is. So you use all your synthetic chemistry techniques, your purification, and your careful kind of recipe where, this step is followed by this step, etc. You'll kind of hear that later on. And then you got a great result, you published and you're lauded. But then the people that are more honest will say, hey, that wasn't realistic. That wasn't right that you were representing it as that. So you get the people that are trying to get the headlines, and they're really kind of doing a lot of human intervention and representing that as prebiotically realistic, and it's not. It's delusional at best. It's dishonest and fraudulent at worst. But hey, that's a lot. That's practically the whole abiogenesis industry, because if they were kind of do honest experiments, they just kind of make these little prebiotic soups and just see what happens. So there's a tension here. The people that really like we want to have an honest experiment, but if we have an honest experiment, we don't have any results except to say it just stayed dead. And if you have a dishonest experiment or delusional experiment, you do all those manipulations and then you just pretend, or you delude yourself to think, oh, well, that can happen in a prebiotic environment, and that's not really right. So let's go on. But the alternative is divine intervention. And he said, yes, most of us are not comfortable with the idea of divine intervention in this context. It is not easy to compute a score for how prebiotically plausible an experiment is. I think it is like saying how improbable it is. I mean, I don't think it's that hard. Let me give an example. Hang on, I lost my internet. 1 second. Hopefully I'm back online. Can you hear me? Let me know if my audio is coming through. Greetings, bread of life. Adios, amigos and amigas. Be well. Dios la bendiga, Jesus Garcia. So hopefully my audio is back, guys. Okay, audio and visual is good. Thank you. Lord help us. Right when it was getting good, my computer bugs out. So I was saying it's certainly possible to give an estimate. What do I mean by that? If a researcher is going to say, this suggests the probability of life, you better, to be honest, say, well, the chance of this being true is 1 in 1,000. And if you can't make an estimate of it, you have no business saying this suggests a possible pathway, practically speaking. Possible is like in Jim Carrey, possible, like 1 in a bazillion. No, that's unacceptable, because, suggests could mean all sorts of things to people, and that's not being straight up. And if you're going to let science popularizers take this, and you really don't know that it could be 1 in a bazillion, and you're letting people think, oh, maybe there's a 30% chance this is the way it works, that's not being honest. And Dr. Change Tan and others, they can show some of the calculations based on the law of large numbers, how probable this is. For example, the RNA world is not honest to be representing that as a possible pathway, when you darn well know, chemically speaking, this is really closer to zero, and therefore, as far as getting closer, it's not legitimate to, getting closer to solving the problem of origin of life, it's not legitimate at all. You might as well, when it's that close to zero, you might as well say there's virtually no chance. Isn't that honest? Isn't like a 0.000 whatever 1 chance virtually zero being true? Then you don't suggest this is a possible pathway, because it's virtually impossible. So the honest thing to say is, we think this is a very remote, very, very, very remote possibility. Okay, so if you're going to use qualifiers, don't say it suggests the pathway, just say it's a very, very remote and therefore unlikely possibility. This is the pathway. In fact, the standard I hear for other peer-reviewed papers making a claim that something is true is usually about 95% confidence. If your confidence, and you know it, and other people have pointed it out, is like almost next to zero, that paper should be rejected as a plausible pathway. If you're claiming it's a plausible pathway, what would be honest to say then is, this doesn't look like a plausible pathway given all the interventions. Isn't this the more honest thing to say? Given we've done all this intervention and given all our calculations, this isn't a plausible pathway, publish it. That's honest. But you know what? That just doesn't fly, because we have a culture now that, in the peer-reviewed community, they just want to hear it. And there's this disconnect. I don't get it. It doesn't make sense. There have been a few that are honest enough. This is one paper that is reasonably honest about what's going on. So let's go on here. It is not easy to compute a score for how prebiotically plausible an experiment is. Often, if a reagent, that is an ingredient, they call it a reagent, Often, if a reagent has already been found somewhere in the geosphere, it is considered plausible, and if it was taken from the catalog of a chemical supplier, it is not. Is this reasonable? Further, how likely is it that a series of transformations occur that require vastly different conditions in a specific sequence? It is not easy to gauge, even for a specialist. All right, so let's just say the honest thing then is we couldn't gauge how probable this is. Don't say it suggests the pathway if you can't calculate it. Still, this parameter may be more important than the source of the chemicals. Temperature changes are plausible based on seasonal changes in day-night cycles. Hydration and dehydration are plausible based on rainfall, tides, and other processes in the hydrosphere. But going well beyond a range of, say, minus 20 to 100 degrees for aqueous media, or assuming that Arctic conditions change to volcanic conditions within hours or days, seems unreasonable to me. For processes requiring base pairing outside the active site of enzymes, temperatures above 85 degrees Celsius seem unrealistic based on the known stabilities of duplexes. For base pairing involving single nucleotides, as in genetic copying, we do not see significant template effects above body temperature, 37 degrees Celsius, in primer extension arrays, suggesting that these temperatures are too strongly denaturing. Okay, I just need to say first, this is a little technical, and since I'm not an experimentalist for these sort of reactions, even I didn't completely understand everything. But this thing about denaturing, when you heat up DNA, so you can call DNA kind of a solid, and when it reaches a temperature, what we call the melting temperature, the double helix breaks apart just from the heat, and that's one way it can be quote unquote denatured. It's no longer like a real DNA, and when it's also in that separated state, it's not, it's not as stable. I think it can break apart a little more easily. It's a little bit more vulnerable to damage. So let's go on. Also, how concentrated specific organic compounds may have become in one specific location on early Earth based on temperature gradients and diffusion is unclear. Not every geochemist may agree with specific assumptions, and as a consequence of such issues, scholarly debates over what is prebiotically plausible and what is not have been controversial. Okay, I'm going to tell you just a funny anecdote here. So there's something called the water paradox. So he's talking about what are plausible prebiotic conditions. So the water paradox says a lot of important chemicals for life need water, but also water is bad for forming it. So you can't live with it, you can't live without it. You can't live with water, you can't live without it. I mean, that is in a prebiotic soup. So for example, if you leave a protein, or more specifically a polypeptide, in water, it's going to break apart spontaneously. And then also, if you have isolated amino acids floating in water, they don't spontaneously polymerize, that is, connect together. And so water is bad for one part of the reaction. But then conversely, you need water to be alive. And obviously our bodies, like say, in cells, they have water in them, and they're they mix with the proteins, and there has to be mechanisms to help recycle or repair the proteins, because um, they can degrade over time. And so that's called the water paradox. The problem then, someone said, hey, we figured out a way to get around that. Let's just assume that the earth is full of formamide or some other chemical like that, and that'll solve the water paradox. So just because water would cause problems, they just said, well, there had to be lots of formamide all over the earth, and there's no proof of that. No proof of that there was lots, and that would also cause other problems, because how do you go from a living creature that is based on formamide in a formamide environment? How does that transition to water? So it doesn't necessarily solve anything. But anyway, that shows how they can just concoct prebiotic conditions without any proof. So let's go on. Plausibility is important. So perhaps it is time to think about ways out of the hand of God dilemma. 3 things come to mind. Well, actually, I don't think you're going to get out of the hand of God dilemma, because God did it. Just a thought. First of all, I feel it is reasonable to report the number of manual interventions during an assay explicitly. An assay, or like your experiment, so to speak. Just to report the number of manual interventions. This number can be quite high, as in the case of enzyme-free replication from activated nucleotides reported by us. And in that long list of publications, he's actually showing, his papers would show all the steps for some of his synthesis experiments. Anyway, this number can be quite high, as in the case of enzyme-free replication from activated nucleotides reported by us, where washing and deprotection steps are necessary to be able to measure the level of misincorporation of nucleotides mass spectrometrically. It can also be high for multi-step synthesis mimicking entire biochemical pathways. Okay, let me just pause a little bit here and try to explain what he's saying. Okay, so your body, the cells of the human body have approximately 3.3 billion gigabases, billions of bases per cell, billions. So the way, if we wanted to synthesize this in the lab from scratch, like if you just had a computer program and said, I want to make a DNA sequence, at most, our best technology will give you about 100 nucleotides. Otherwise, it starts not to work so well. And you have to build it 100 nucleotides at a time, and then hopefully you can try to stitch it together. All right, it's a really painful process. But even for 100 nucleotides, you have to protect, you wash, and you attach a new. So you start off with one, say, nucleotide. You deprotect. You add another nucleotide. You wash it, clean it, and protect, and then at some point you have to do more chemicals and then deprotect, add the next. So even for like 100 nucleotides, you've probably got, say, 400 separate recipe steps. And like the topoisomerase protein is what, 1,500? So roughly, in terms of DNA, to make a functioning topoisomerase, you would need 4,500 nucleotides. This would be like roughly 14,000 steps that have to be done in order correctly, chemically. So if you do count this up, it starts to be staggering, and that's only one protein. So let's go on. It can also be high for multi-step synthesis, mimicking entire biochemical pathways. Understandably so, as self-organizing biochemical cycles are difficult to demonstrate experimentally. Usually one tries to keep the number of steps in the single-digit range. Yeah, single-digit range. When it becomes unavoidable to intervene as experimentalists, just state the number of discontinuities in the experimental conditions or human interventions. What you don't do is what Dave Farina says, it's really easy to make a biomolecule, any biomolecule. It's just ridiculous. So let's go on. Secondly, one may want to state more explicitly what prebiotic scenario a specific experiment is believed to address. This will not solve the hand of God dilemma, but may allow the reader to gauge what geochemical conditions were assumed when the experiment was planned. Is the experiment focused on the formation of simple biomolecules from inorganic precursors? Is it an experiment aimed at understanding the reactivity of such biomolecules? Or is it an experiment tackling multi-step processes, such as the synthetic pathways or genetic replication? What is the presumed stage of prebiotic evolution that is the backdrop of the experiment performed? Thirdly, it makes sense to reduce the number of interventions required for an experiment by employing non-invasive spectroscopic techniques and building on known reaction networks that produce multiple biomolecules in one solution. The power of multidimensional NMR, that's nuclear magnetic resonance spectroscopy, combined with modern mass spectrometry, allows one to monitor multiple biochemical species in one solution over extended periods of time. That is, one way that we can run tests on what's in the mixture without actually changing the mixture. Materially, that is. The analysis of the data can be a time-consuming jigsaw puzzle to solve, but this is well worth the effort, given that this can minimize the number of interventions. A final word of caution. Life is a non-equilibrium phenomenon. It requires an energy source that drives its reactions. Assuming that simple heating-cooling cycles could have driven the formation of functional biomacromolecules that were then able to harness the energy emitted by the sun via photosynthesis seems unrealistic to me. Achieving the level of specificity required to successfully operate a protocell with genetic apparatus, metabolism, and cell division under strongly denaturing conditions is not easy. Certainly when it comes to enzyme-free replication, relying on the intrinsic specificity of small molecule interactions. Okay, so let me just try to uncoil this. Say a denaturing environment, that would be one that's high temperature, for example, where it has a lot of chemicals that would just break apart the prebiotic chemistry and make it even farther from becoming life. And then he talks about enzyme-free replication. So when I was talking about like the man-made DNA, it needs a robot basically to be doing all the chemical washing and connecting, and it's a very painful process. And that's an example when it's enzyme-free. You instead of the way we replace the enzyme-free to make man-made DNAs, we have this very complicated machine. And so it's not trivial. It's not trivial. So the periodic addition of a chemical condensing agent may be unavoidable to drive biochemical reactions that are endergonic, even in the minimal intervention experiments. Let me look up the word endergonic. Hang on, I'm going to go to my other computer. Endergonic. Endergonic, of a metabolic or chemical process accompanied by or requiring the absorption of energy, the products being of greater free energy than the reactants. Okay, so you just have to add energy. I'm just checking the audio here. Okay, thank you. So the periodic addition of a chemical condensing agent may be unavoidable to drive biochemical reactions that are endergonic, even in minimal intervention experiments. Okay, so synthetic chemists would totally understand what this is. Without the chemical, I'm sorry, I should have shown this. Without the chemical activation, equilibrium, that is death, death sets in. So some level of human intervention may always be required for complex multi-step processes. After all, what the dominant activation agent was before enzymes began to use ATP will remain an enigma to many of us for this foreseeable future. After all, what the dominant activation agent was before enzymes began to use ATP will remain an enigma to many of us for the foreseeable future. So, a lot of enzymes are able to do their thing because they're powered by the chemical ATP. That seems to be a very common currency for energy. It's kind of like standardized fuel. And how is it powered prior to ATP? So there's the assumption then, how is the reactions able to be powered before ATP? Because you could assume then ATP was available, but then you had the problem. Then if you assume that, you have to eventually explain where it came from, and the prospects of how it came from is not very good in a prebiotic environment. I mean, there are pathways outside of ATP synthase and some other pathways in living things. There are pathways outside of that can hypothetically make ATP, but it may not be in high concentrations. And how do you get it to be in the right place? You need to, and then also have an enzyme ready to use it. So there are problems here. And greetings, Bubblegum Gun and Gangster Ghost. Nice to see you. Thanks for visiting. And we're just wrapping up the stream after about an hour. So this was a good opportunity for me to just read this. I may be using it in my debate tomorrow, so I hope you all will join me for the debate. I'm hoping to also have maybe a minor after show afterward. So thank you all for joining me. Take care, and the Lord Jesus richly bless you. Take care.